In this video, we're going to calculate average atomic mass. We will go through two examples. We'll start with an easy one, and then we'll advance to a slightly more challenging one. First of all, before we start diving in a calculation, I think it's a good idea to first understand what exactly is an average atomic mass, or more often just called by as atomic mass. If you look at the periodic table, it's that larger decimal number. In this case, for oxygen, it's 15.999, so that's the larger number and it's in decimal place. It's actually a weighted average that takes into consideration the mass of each isotope that is present in nature. When it comes to calculating the average atomic mass, you'll often hear the word abundance. It's basically how much you can find that specific isotope on Earth. All the abundance for all the natural isotopes will have to add up to 100%. That's really important. So how do we calculate this atomic mass for an element? What we have to do is basically multiply the mass of an isotope with its abundance, and then do the same thing for the other isotopes and then add them all up. And that will give us the atomic mass for that specific element. Let's try using the formula on our first example. This is a pretty straightforward question. It gives us the isotopes, individual atomic mass, and its abundance. Recall from the formula for atomic mass, it's the sum of mass times abundance for each of the isotopes. So we multiply 15.9949 with its abundance, which is 99.757. Notice it's in percentage, so we will need to divide by 100. If that value for abundance is given in decimal, like for example 0.99757, then you don't have to do anything, just use that number. Okay, so now we move on to the second isotope, which is 16.9991, and then we times it by 0.038 divided by 100. And finally, for the third isotope, it's 17.9992 times 0.205 divided by 100. And what we get is 15.956 for the first isotope, plus 0.0065 for the second isotope, plus 0.0369 for the third isotope. So we add them all up, and that will give us 15.9994. And the unit here is AMU, which stands for atomic mass unit. Sometimes you'll only see U is used as the unit, which represents just unit. So just go with whatever the question gives you. Looks like we have calculated the atomic mass successfully, since it is the same value that we can find in the periodic table. Now this is a straightforward question. Let's move on to another question which is not as straightforward. This question is telling us that nitrogen has two isotopes, which is nitrogen 14 and nitrogen 15. It gives us their masses, but it didn't give us the abundance. And we're supposed to figure out the abundance for each of the isotope. Let's start by writing out the formula to calculate the atomic mass. Since we only have two isotopes, we only need to add up two terms, right? So the first set is for nitrogen 14 and the second set will be for nitrogen 15. Let's proceed, and it looks like we need to figure out the atomic mass of nitrogen, and we can easily find this from the periodic table. It's 14.0067. As for the abundances, we know that both the abundance for nitrogen 14 and nitrogen 15 will have to add up to 100%, or just 1. So therefore, we're going to use X for the nitrogen 14 abundance, and that will make nitrogen 15 abundance 1 minus X. Note, you do not want to use Y or any other variable for nitrogen 15 abundance, because it will make it impossible to solve it mathematically. You have one equation with two variables, that's a no, no, no. One equation, one variable, yes, we can handle that. So just bear with me if that doesn't make sense. You'll see in time what I mean. Let's plug in everything into the equation. So we have 14.0031 times X plus 15 times 1 minus X. So we need to expand the equation, and here's what we get. And we rearrange the equation a little bit in order to solve for X, and that gives us 0.0934 equals 0.997X. And we solve for X by dividing 0.9934 with 0.997, and that will give us 0.9964. So we found that nitrogen 14's abundance is 0.9964, and that's in decimal place. So we need to convert that to 100% simply by multiplying with 100%. And so that will give us 99.64%. So the abundance for nitrogen 15 is going to be 1 minus that, or 100% minus 99.64. And so that will give us 0.36%. That's it. We have solved the question. To recap, atomic mass for element is calculated by multiplying each isotope mass with its abundance, and then we add them all up. So keep in mind that the abundance of all the isotopes should add up to 100%. And also, if the abundance is given in percentage, be sure to divide it by 100. If it's given in decimal number, just use as it is. Hope the video on calculating atomic mass was helpful. Do subscribe, and thanks for watching.